Assalamu alaikum dear students, welcome back to Dr. Zakir Math. In today's video, we are going to learn a very useful method and interesting one in numerical analysis is Newton's divided difference formula. What is the use of this? Let me tell you. Have you ever wondered how engineers and scientists estimate the unknown values? What do you mean by estimates? Look here, they are asking you calculate the value f of 2.3. Where is 2.3? At x is equal to 2.3, in between 2.2 and 2.4, right? So in between 2.2 and 2.4, 2.3 is there. So you are going to estimate this unknown value when you have few set of data points. How much of data points you have? 1, 2, 3, 4, 5. Right. So this method allows you to build a polynomial that fits exactly through the known points. So these are the known points. First, you try to fit a polynomial. Once you fit a polynomial, then you can calculate any type of unknown values. So we will solve examples step by step. So you will see how to construct the polynomial and approximate the function easily. By the end of this video, you'll be very confident in using this method in your engineering courses. So let's get started. Yes, usually chemical engineers, they use a lot Newton divided difference and Lagrange's interpolation. So first we have to calculate the Newton's divided difference table, right? Interpolation table. Yes, we will take the values now. Before going to that, I just wanted to say that now 2.3 is very close to what? 2.3 is very close to what? 2.2 and 2.6. So that's why I'm going to choose only 3 points. I'm going to choose how many points? 3 points, which is near to 2.3. Look here, this is the value you're going to calculate, which is near to 2.3. So when you're near to 2.3, that is 2.2, right? And then I'm going to choose 2.4 and then 2.6. For 2.2, your value is 15.113 and 2.4, your value is 20.243 and this is 27.403, right? These are the 3 points I'm going to take it for the problem. So actually this is your problem. Even though the problem is so many data points are there, but we are going to consider only these 3 data points, right? So let's create the interpolation table. So let's take x and y and delta y and delta square y. Usually for divided difference, I will make a center. There is a one line I will make it for unequal intervals. I told you in the last video. So my point is 2.2, 2.4 and 2.6. Y value is 15.113. Only I remember this. Let me go back. 2243, 27403. Okay. So 2243 and 27403. So this is your x0 and this is your x1 and this is your x2, right? And if this is x0 and this will be y0, this will be y1 and this will be y2, right? So del y, how you are supposed to calculate, del y0, del square y0. How you are going to calculate? This value minus this value divided by this value minus this one. So it means 20.243 minus 15.113. Let me reduce the font size, just a minute. So divided by, yes, the value is 2.4 minus 2.2. Let me use the calculator. 20.243 minus 15.113 divided by 2.4 minus 2.2, which is equal to 25.65. Next is 27.403 minus 20.243 divided by this value minus this value. 2.6 minus 2.4, right? 2.6 minus 2.4. So let me put in the calculator. It will be 35.8. So the next is del square y0. Let me make a line here and over line here and over a line here. So next is 35.8 minus 25.65. This minus this. And then before you started from here, now you have to start one step down. So which is 2.6 minus 2.2. If I put this in the calculator, I get 25.375. Actually, I stop the video and then again I just do the calculator, because so that you will not forward the videos. Guys, I told you many times, if you really understand this video, please like and give it a thumbs up, I said. But you are not doing. Anyway, no problem. So let it be. Now we created the table. So we are going to consider these values. So these values, I'm going to make a table. So these values I'm going to consider. The first values in the table are the polynomial, these values. Yes. So once you consider this one, so what is your polynomial divided difference, Newton divided difference formula? Newton's divided difference formula. Newton's divided difference formula. Okay. For quadratic. It means for what? For degree 2. Formula is f of x equals, which is y naught plus x minus x naught times del y naught, right? And then plus x minus x naught multiply by x minus x1 del square y naught. This is the formula. So this equals y naught value is 15.113 plus, and then your x minus x naught is 2.2. So which is x minus x naught 15.12.2 and times del y naught. This is your del y naught. Okay. And this is your del square y naught. Just make a line, for this is an unequal interval, so you should make a line in the center of delta. 2.2 and then del y naught is 25.65, and then plus x minus 2.2, x minus x1 is 2.4 and del square y naught is 25.375. So 25.375. Okay. So this is called Newton's divided difference interpolating polynomial. Okay. Suppose the question is asking, find the interpolating polynomial or interpolation polynomial. So this is the polynomial, Newton's divided difference interpolation polynomial. But now they ask you to estimate the value f of 2.3. So f of 2.3, you are going to calculate f of 2.3. So it means you are going to put x is equal to 2.3. Okay. So when I put x is equal to 2.3, directly you can put in the calculator 2.3 minus 2.2 and 25.65 plus 2.3 minus 2.2 times x minus 2.4 times 25.3375. Okay, if I put all these things in the calculator, f of 2.3 is 17.42425. I got it. Teacher, do I need to fix 3 decimal, 4 decimal? Just see the y values. According to that, you can fix the decimals. Y values are what? 3 decimal values. So try to fix 3 decimal values. If not, it is okay, no problem. Anyway, the 4th decimal is less. Clear, all of you? One thing, after finishing the problem, try to check your answers. How, teacher, I can check? Just a manual check. Look here. 2.2, it is 15 point something, right? And 2.4 is 20 point something. Now we are calculating 2.3, right? So the answer should be in between 15 to 20. The answer should be what? In between 15 and 20. So this finishes this question. It's a very important question, Newton's and Lagrange's. So might be already you studied in the class. So anyway, so this I'll give you one practice problem also. You can try at home and give me the answers in the comment section. Yes, this is the problem you can try at home. That is 1.0, 1.2, 1.4, 1.6, 1.8. And f of x values, you can see it is 3 decimal values. Use Newton's divided difference formula for degree 2 to approximate f of 1.3. I have given the answer also, 3.684. Right. So this finishes Newton's divided difference formula interpolation. Okay. Right. So great job, students. Now we have seen how to construct Newton's divided difference polynomial and use it to approximate the function values. One thing you remember, always choose points close to the value you want to estimate. That is very, very important. Again, I'll repeat, always choose points close to the value you want to estimate. What is that? We are going to estimate 2.3. So choose one value before, one value after. That is very, very important, so that the result will end up quickly. Without choosing also, you can take the whole table, but it takes a lot of time to finish it. Check your result to make sure it makes sense. What is the meaning? It makes sense. I told you, right? In between, we are taking the value. So 15 to 20, the answer should come. Your answer should not come something like 120, 140 point something. So it should be sense. So check your results to make sure it makes sense. Try the practice problems I have shared and write your answers in the comments, please, whether you got it or not. If you found this video helpful, please don't forget to like, share and subscribe to stay updated with more math questions. Keep practicing and math will become much easier. Finally, East or West, Dr. Zahid Math channel is the best. See you. Take care. Bye bye.